Hello. In this lesson we are going to take a look at geometric sequences. In the last lesson our focus was primarily on arithmetic sequences. Arithmetic sequences are ones which grow through constant addition. So from one term to the next you'll add the same value each time. The difference between arithmetic and geometric primarily is that these sequences are going to grow through a constant operation, but now it's going to be multiplication or division as opposed to addition or subtraction. So arithmetic sequences had a constant difference between successive terms, which we called that value d. Geometric sequences, these are going to have a constant ratio between successive terms. We'll denote that variable as r. So the way we found a constant difference was we took the new value in a term, any term which we considered to be the new one, and we subtracted the old term. New minus old equaled the constant difference. Constant ratio is going to be found in a similar fashion. We're going to use a newer term and an older term, and it doesn't matter which ones we use. We could say this is the new term, this is the old term, or this is the new term, this is the old term. Doesn't matter. Constant ratio is going to be found by taking a new term and dividing by an old term. So in this case, if we were looking for the constant ratio of this geometric sequence, we take any term, which we consider to be the new term, we divide by the old term. So here I'm going to choose 18 as my new term, 6 as my old term. So the constant ratio for this sequence is going to be 3. If you see a constant ratio that is a value that is larger than 1, the sequence is going to grow. It's going to get bigger as you go along. If you find a constant ratio that is between 0 and 1, it's going to get smaller. This is pretty much what's going on. What's pretty much going on right now is what we discussed whenever we learned about exponential functions. You probably remember if you had a base bigger than 1, we had growth, and if you had a base between 0 and 1, you had decay. So growth went up, decay went down. It is possible in sequences to have a constant ratio that's negative. That wasn't a possibility whenever we discussed exponential growth. So it is possible for us to see a sequence that goes 8, negative 4, 2, negative 1, 1/2, etc. If we were going to find the constant ratio for this, we take any term, we consider it to be our new term, and then we take the old term, and we're going to do the new divided by the old. So 2 divided by negative 4, which would be negative 1/2. You see we have a constant ratio that's negative. And if you consider that absolute value of negative 1/2 to be between 0 and 1, which it is, you can see the overall value of the terms is going down. 8, 4, 2, 1, 1/2, etc. In the next video I'm going to go over some examples of how to continue to make the terms of a sequence.